Hi guys, today we're going to take a look at some more graphing practice. So we're on pages 16 and 17 in your unit notes packet. So we're going to look at some matching graphs, and then we're also going to look at some problems where we have a function that we're going to graph ourselves. So to start, let's actually talk about some of the features that we're going to see in our graphs. One of the important ones that we're going to see as we look at these exponential functions is something called the asymptote. So an asymptote, remember, is this sort of invisible line on my graph that my function graph can get really close to, but will never touch or cross. So it's a line that the graph approaches as you move away from the origin, away from sort of the center of the graph. But your graph can never touch or cross that line. If I look at a function given to me here, like number 2, my asymptote for my parent function, so if I looked at something like y equals 2 to the x, the asymptote here would be the line y equals 0. That's my sort of default position for an asymptote. But anytime I have a vertical translation, a shift up or a shift down, then my asymptote shifts as well. So I can look at my function, look at the end. If I'm adding or subtracting anything, that's my asymptote. So here, our asymptote would be the line y equals 3, since we're shifting up 3. If I had something like number 5 down here where I've got -2 at the end, then our asymptote would be the line y equals -2. So it should always be easy to pick out the asymptote. If I see a number there at the end that I'm adding or subtracting, it's that number. If I don't see a number that I'm adding or subtracting at the end, then it would just be y equals 0 for your asymptote. Okay? So with that idea in mind, let's take a look at some of the functions that we have here, and we want to try to match them to their graphs. So I'm going to start by identifying if I've got growth or decay. So for number 3, I'm looking at the base for the exponent. That base is bigger than 1, so this is going to be growth. Number 4, the base for my exponent is less than 1, so that's going to be decay. Number 5, the base for my exponent is greater than 1, so that's growth. Number 6, the base for my exponent is greater than 1. I see this negative in front here, but that's actually -1 times 3 to the x. If the -3 were in parentheses, that would mean the negative is attached to the base for my exponent. We're not going to look at any problems here where the base for the exponent is negative, so this isn't something that we need to worry about. So here the base for my exponent is bigger than 1, so this is again growth. For number 7, the base for my exponent is less than 1, so that's decay. Number 8, again decay. Number 9, decay. And number 10, base for my exponent is bigger than 1, that's going to be growth. The next thing I'm going to look at is something you guys looked at in your notes last time, which is the idea that our lead coefficient can flip our graph if it's negative. So if I take a look at number 3, my lead coefficient is negative, so this is going to be flipped. What I expect a growth function to look like is this, but if my lead coefficient is negative, that's going to flip it. So this is going to be a growth that shoots down. Number 6 is also going to be a growth function that shoots down. Number 9 is going to be a decay function that's flipped. So it's going to look like it goes up and then levels out. So it's going to look like this. Number 4 is a decay function. I don't have a negative leading coefficient here, so this will be your standard decay function. Number 7 has a negative lead coefficient, so we're going to flip that decay function just like we did here. Oops. So this will be a flipped decay function. Number 10, since I don't see a lead coefficient, that means it's 1. So this is going to be a standard growth function. Number 5, another standard growth function. Number 8, decay. My lead coefficient is positive, so that's going to be a standard decay function. So if I know information about the shape of the graph, that should help me kind of narrow these down. So for number 3, I'm looking for a growth function that's flipped. So A matches that shape. A is a possibility. Let's see. G would be a possibility. Looks like just A and G here. So to decide between these two, that's where I'm going to look at my key point. So in our sort of early sets of notes, we talked about this C value, this initial value, or that lead coefficient, as I called it a minute ago, being the y-intercept. Now, what we're starting to see here with some of our functions are shifts, vertical shifts, like with 4, horizontal shifts, like we have with the x minus 1 on number 7. So if I have a shift, that's not going to be the y-intercept anymore. But since number 3, we don't see anything up here with x or anything down here, that means my asymptote is going to be at 0, and my y-intercept is going to be 2 away from that. So -2 means we're going down, so I'd have a y-intercept at -2. So between A and G, I want which of them has a y-intercept at -2. Well, that's A. So 3 is A. Now I've got one other graph that's a flipped growth function. So I want to find my other one where I made a flipped growth. That's growth, but the right direction. That's growth, the right direction. That's number 6. So if I take a look at number 6, I should have an asymptote at +3. So G was our other option. If I look here, 1, 2, 3 is where my graph starts to taper off. So that looks promising. And then my key point would have been at -1, but I shifted up 3 and to the right 1. So instead, how I want you to think of this is I should be 1 below the asymptote. So I was 1 below the asymptote, and then I moved to the right 1. So right 1. So go 1 below the asymptote and then move to the right 1. That's our key point. So 1, 2. So 6 matches with G. Okay, so G is done now too. If I take a look at number 4, I've got a decay function that should go the way I expect a decay with a sort of normal decay graph. So I'm looking for decay with a normal decay graph. That looks like E and F are going in that direction that I expect. So I want to look at where's my asymptote here. So my asymptote's at -1. So for E and F, I want to know which of them would have an asymptote at -1. So if I look at E, my asymptote's definitely not at 0 because I have a point at 0. It looks like it could be at -1. For F, this looks like my asymptote's at 0. So between the two of these, this looks like E. So number 4, we're going to go with E. Number 5, growth and going the sort of regular direction for growth. So that could be B or C. So between B and C, I need to know which has a matching asymptote. I'm going to start there, asymptote at -2. Well, C has an asymptote at 0. B has that asymptote at -2. So 5's got to be B. And now let's move on to 7. So for 7, I've got decay, and it's going to be flipped. Decay and flipped. Decay and flipped. So that could be D or H. D or H. Let's take a look at our asymptote here. We're adding 3 at the end here, so I expect an asymptote at 3. H has an asymptote at 0, but D has an asymptote at 3. If I wanted to check further here, again, I could look for that key point. So I've got this -1 in front. So that means I'm going to go 1 down from my asymptote and then to the right 1. So if I look at D, I'm going to go 1 down from my asymptote and then to the right 1. And that is the point on my graph. So the 7 is D. Number 8 is decay, sort of the original shape decay graph. So we're looking at F. And at this point, F is the only, I think, originally shaped decay graph of the ones I have left, but still a good idea to check its features. So for number 8, my asymptote is going to be at 0. So that's right here. And then my lead coefficient, my initial value here would be 1. So this would be 1 since it's positive up from the asymptote. So 1 up from the asymptote. And then this -1 in the exponent is going to move me to the right 1. So 1 up and right 1. And I've got a point on my graph. So this matches with F. 8 matches with F. For 9, same idea. Decay graph, but flipped since I have that -1 in front. So decay graph, but flipped. So probably H here, but I'm going to check that key point just to be sure. My asymptote would be 0. Since I don't see anything here, that means it's 0. Not adding or subtracting anything at the end. So let's check our asymptote. Yeah, asymptote at 0. And then my key point is telling me 1 below the asymptote. Since it's -1, 1 spot below the asymptote. So 1 spot below the asymptote. And then we don't have anything in our exponent, so we're not moving left or right any. So just 1 spot below the asymptote. There we go. That's H. And then our last graph here, 10. Growth, going the direction I expect. It's not flipped. Our only option left is C, so that kind of narrows it down. But if we just check those key features, I don't see anything here at the end, so that means my asymptote is going to be 0, which we see on the graph of C. And then if we check our key point, this says it should be 1 above the asymptote, so 1 above, and then the -2 in the exponent is going to move us to the right 2. So 1, 2. There we go. There's that key point on our graph. So 10 is C. So we've taken a look at some graphs with this sort of matching setup. Now I want to take a look at some graphs that we create. So let's take a look on the next page at number 11. So we've got our function here, and I want to graph this. We're going to include 3 accurately placed points and the asymptote. Anytime you graph an exponential function for me, I need to see the asymptote on that graph. And I'm asking for 3 accurate points here. Okay, so let's go ahead and start with the asymptote. That's the easiest thing to find from your function. It's the easiest thing to graph because it's just a horizontal line. So if I look at my function, I'm not adding or subtracting anything at the end here. That means that my asymptote is 0. So I'm going to go to where y is 0, and then we're going to stretch that across our graph. That's our asymptote. Okay, there's our asymptote. And it asks me to state the asymptote. That's also an easy thing to jot down, y = 0, okay? From here, I wanna get that key point, okay? And I'm actually gonna jot that down because that's an easy place to sort of plan my graph around. So if I take a look at this lead coefficient, that lead coefficient is 2. So that means, since it's positive, that means I'm gonna go up 2 from my asymptote. And then the -1 in the exponent is telling me to go to the right 1. So up to right 1, there's my key point at 1, 2. 1, 2 is my key point here, okay? Now it also wants me to state the y-intercept, and I need 3 total points. So just that 1 point isn't gonna cut it. Since I want the y-intercept, I'm gonna go ahead and make a table. And I'm going to plug in x is 0 so that I can get the y-intercept. I already know I have the point 1, 2. So my third point, maybe I'll try the point 2, something. To figure out the y values for these other points, I'm just going to plug the x value that I've selected into my function. So when I plug in x is 0, that would be 2 times 1/3 to the 0 minus 1 power. 0 minus 1 is -1. So I've got 3 to 1, or I should say 1/3 to the negative first power. Remember, a negative exponent flips my problem, okay? So this would actually be 2 times 3 to the first. I'm going to flip that, and then the exponent is positive. Okay, so 3 to the first is just 3, so 2 times 3 is 6. So my y-intercept would be at 6, and it asks me to state the y-intercept, 0, 6. So this is also a point that I could plot. 1, 2, 3, 4, 5, 6. There we go. And then I've got to find one more point here. So I'm going to plug in 2. If you want to plug in a different number, you can. I'm just picking stuff that's close to that key point. So I'm going to plug in 2 for my exponent. So this would be 2 times 1/3 to the 2 minus 1. So I'm going to simplify in my exponent first. 2 minus 1 is 1. So I have 2 times 1/3 to the first power. So 1/3 to the first power is just 1/3. So I've got 2 times 1/3. Okay. And now 2 times 1/3 would just be 2 over 3. It's okay that I have a fraction here. That's fine. You don't need to change these to decimals. I would rather you practice your number sense than just go to type stuff in the calculator. So 2, 1/3, little estimating there because this is a fraction, but it's got to be above my asymptote, but less than 1. So there's my graph. There's a graph of this function, okay? It's got 3 accurately placed points. I've listed them here, so I know what points I expect to see on my graph. I've stated my y-intercept, I've stated the asymptote, I've graphed the asymptote, and I've stated my key point, okay? You guys are gonna have a quick check where I'm gonna ask you to do these things. Give me a graph with 3 accurate points, state the y-intercept, graph the asymptote, and state that equation, and then give me the key point. So we just did all those things here. Now we're going to do it again with another function. So for number 12, exact same idea, just a new function. So I'm going to start again with the asymptote. Since I don't see anything at the end here, that means that it's 0. So my equation for my asymptote is y equals 0, and I'm going to go graph that on my coordinate plane. This is the easiest part, is getting that asymptote on there, and that's where I want you to start. Next, I'm going to go ahead and graph my key point, and I'm actually going to jot down my key point as I'm going. So my lead coefficient is -2. That tells me from my asymptote, go down 2 places. And then because I have +2 in the exponent here, that's going to move me to the left 2. So my actual point will be down 2 and then left 2. So my point is right there. Okay. Now that would be the point -2, -2. So I want to list that in my notes here. And then I need the y-intercept, and I need 2 more points. So I'm going to again make a table. So x, y, y-intercept happens when x is 0. I've also already have the point -2, 2. So I'm going to try and get the point -1, whatever. I'm just filling in the one that's in between those. If you wanted to go forward to +1 and find a point over on this side of the graph on the right-hand side, that's fine too. Pick what you want. You have to give me that key point, and I'm asking you to give me the y-intercept. So this one could be whatever you want, okay? But if it's way off the graph, that's not gonna help you. So that's why I pick something in between these. Okay, so y-intercept, that means I'm plugging in 0 for x. So this would be -2 times 3 to the 0 plus 2. So 0 plus 2 is 2. 3 squared is 9. So I've got -2 times 9. Make sure you're following order of operations here. And then -2 times 9 would be -18. So I know the y-intercept, but that's going to be way off my graph. So the y-intercept is 0, -18. Maybe when I plug in -1, I'll get something a little bit nicer. So -2 times 3 to the -1 plus 2. I'm plugging in -1 for x. So -1 plus 2 in the exponent is just 1. So I've got 3 to the first times -2. So that would be -2 times 3. -2 times 3 is -6. -6. That's a point that will fit on my graph. So -1, comma, -6, 1, 2, 3, 4, 5, 6. There we go. I know my y-intercept is going to be like way down here somewhere, right, on my like next graph, but putting it on the next graph isn't very helpful for me. So instead, to find my third point, I'm actually going to go back this way one. I'm going to plug in x is -3. So -2 times 3 to the -3 plus 2. So I plugged in -3 for x there. Simplifying my exponent, -3 plus 2 would be -1. Since this is to a negative exponent, that means it's going to flip. So this would be -2 times 1/3, which would be -2/3. So -2/3 is that y value there. So 1, 2, 3, and then -2/3 is going to be like right there-ish. Okay, so there's 3 accurately placed points. I'm going to sketch in my function, and there's my graph. Now we're going to take a look at one more together. So let's take a look at, we'll take a look at number 13. Okay, I've got an asymptote that's not 0 for this one. I've got +1 at the end. That means my asymptote would be y equals 1. So I'm going to go to, oops, let me get rid of this blue mark here. There we go. Now I need my pen back. Oh. Okay, there we go. So I'm going to go to where y is 1 and then sketch my asymptote. And now I want to find that key point. So this lead coefficient right here, that initial amount, that C value, whatever we want to call it, this tells me that I'm going to be 4 above my asymptote. Since it's +4, that's 4 above. So 1, 2, 3, 4 above. And then the -3 in my exponent tells me to move to the right 3. So I went 4 above, and now I'm going to go 1, 2, 3 to the right. There's my key point. So my key point is at 3, 1, 2, 3, 4, 5, 3, 5. 3, 5 for my key point. And now I want to find 2 more points on this. One of them is going to be the y-intercept again, and then another point that fits nicely on my graph. So I'm going to, again, make a table. So x and y. I already have the point 3, 5. I want the y-intercept, so I need to plug in x is 0. And then I'm going to try 1 and 2. And I've got 3, 5 already. I'm putting in both 1 and 2 here because I have a hunch that my y-intercept, my y-intercept is going to be way off my graph. There we go. I have a hunch that my y-intercept is going to be off my graph. Hopefully I'm wrong and I can use the y-intercept and I only need to plug in one of these, but just in case I put the other one in there as well. So here I'm going to plug in 0 for x. So this would be 4 times 2 to the 0 minus 3 plus 1. So I'm going to follow order of operations here, step by step. By simplifying the exponent, that's -3. 2 to the -3rd would be 1 over 2 cubed. So what I have here is 4 times 1 over 2 cubed is 8, and then plus 1. So this would give me, from just this part here, 4 over 8. That simplifies to 1/2. So 1 plus 1/2 would be 1.5, or 1.5 if you like the decimal version better. Okay, so I'm going to plot that 0, 1.5. Okay, add off my graph. Great. Now I'm going to plug in my next x value. My next x value is 1. So this would be, I need to state my y-intercept, 0, 1.5. And then I'm going to plug in my next value for x. So this would be, do this down here, 4 times 2 to the 1 minus 3 plus 1. Again, order of operations as I simplify step by step. 1 minus 3 is -2. So this would be 1 over 2 squared. Since I have a negative exponent, I need to move it to the bottom of this sort of fraction that I have here. So this would give me 4 times 2 squared is 4, so 1 over 4 plus 1. So this part here, just this part here, 4 times a fourth would be 4 over 4, right? Multiply the tops, multiply the bottoms, which is just 1. So I get 1 plus 1, which is 2. So I have the point 1 comma 2 on my graph. And then just for a little extra practice, I'm going to go ahead and plug in the other x value that I selected. So this would be 4 times 2 to the 2 minus 3 plus 1. 2 minus 3 in the exponent gives me -1. So this part right here would be 1 over 2 to the first, or just 1/2. So I've got 4 times 1/2 plus 1. 4 times 1/2, if I multiply them like fractions, I would get 4 over 2, or half of 4 is 2. So this part's 2. 2 plus 1 gives me 3. So 1, 2, 1, 2, 3. There we go. So this one actually I gave 4 points. And I've got the graph of my function. I stated my y-intercept. I stated my key point. I gave the equation of my asymptote. I have my asymptote graphed on my function. Okay, so this is what I'm going to ask of you anytime that you graph an exponential function. I want 3 accurate points so we can see the shape of that graph. Just the key point doesn't tell me the shape of my graph. 3 points gives me a good shape. And you always need to include your asymptote in your graph. That's important. We need to see it, okay? So you can go ahead and try 14 and 15, and then you'll have a quick check that will ask you to do exactly this same step. So if you can do it here, you can do it there.